Children.
Sorry, he said something.
We're on the little TV again, so if you need to adjust your seats, feel free. All right, it says plot the point and find 3 additional polar representations of the point using negative 2 pi to positive 2 pi, then find the rectangular coordinates for the point. So the first thing I'm going to do is actually plot my point. So I'm going to bring in a polar coordinate grid. If you weren't here yesterday, I told them to download the one that was on the assignment because we're going to use that a lot. I bring in my polar coordinate grid. And then for 2 pi over 3 says to go to 2 pi over 3 on my unit circle, which is in the second quadrant. And it's a positive 4, so I go out to the 4th ring and I plot my point. That's where that coordinate point lives. Then to find your additional polar representations, you have 2 options. The first is keep the r as it is and add and subtract even multiples of pi, which we start with 2 pi usually. We add and subtract 2 pi. Then the other option is change the sign on r and add and subtract odd multiples of pi, which normally we start with just pi. But there was one in the homework that you couldn't just use pi, you had to use 3 pi. So it's any odd multiple of pi. All right, so if I look at this, and in the end, if you're between negative 2 pi and positive 2 pi, and you're looking at 4 points, including the one that's given to you, 2 are going to have a positive r and 2 are going to have a negative r. Usually 2 have a negative angle and 2 have a positive angle. Okay, so that's kind of like if you are trying and you can't figure it out, you only have one negative r, you're looking for another one with a negative r. And if you only have one positive r, you're looking for another one with a positive r. So I'm going to keep my r as is, and I'm going to take that 2 pi over 3. If I add 2 pi to it, which would be 6 pi over 3, it's 8 pi over 3, and that's too big. So the other option is to subtract 2 pi, which is 6 pi over 3, and I get negative 4 pi over 3. And that falls between negative 2 pi and positive 2 pi. So that's one of my options. I kept the r, and I have negative 4 pi over 3. Then I already have the positive that was given to me, so I'm going to change the sign. I'm going to make it negative 4. And I'm going to add and subtract odd multiples of pi. So 2 pi minus pi would be 3 pi over 3. And I get negative pi over 3, and that falls in between negative 2 pi and positive 2 pi. So that one's another option, negative 4, negative pi over 3. And then I would take my original coordinate point, angle 2 pi over 3, and I would add pi, which is 3 pi over 3, and I get 5 pi over 3, which is in between negative 2 pi and positive 2 pi. So that's my third coordinate point. Now, if I were to graph each one of those, they should overlap at the same point. So if I graph positive 4, negative 4 pi over 3, negative 4 pi over 3 would be at 2 pi, because that would be down here, positive, fold it in half like a hamburger, and it's at 2 pi over 3, go to the 4th ring, that's it. If I wanted to graph negative 4 and negative pi over 3, negative pi over 3 is here at 5 pi over 3, but it's a negative r, so instead of going towards it, I go away from it. 1, 2, 3, 4, same coordinate point. And then if I wanted to graph negative 4, 5 pi over 3, I'd go to 5 pi over 3, 4th quadrant. Negative 4 says again, count away from it, and I overlap the same point. So if you did it correctly, they would all be plotted at the same point. Correct. And if this was on WebAssign and it asked you to put it in order of least angle to greatest angle, the furthest negative obviously is going to be the smallest. So this would be smallest, then this one, and then this one if I put them in order. Second part of this question says find the rectangular coordinates for the point. So we're going from polar to rectangular. And the formula for that is r cosine theta and r sine theta. So my r was 4 cosine 2 pi over 3. And my r again is 4 sine 2 pi over 3. 2 pi over 3, if I have the visual, which is here, okay, maybe that helps, is in the second quadrant. So it's going to have a negative cosine and a positive sine, and it's an over 3. The over 3 coordinate point is 1/2 and root 3 over 2. Again, the cosine would be negative because it's in the second quadrant. So this is 4 times negative 1/2 and 4 times positive root 3 over 2. So 2 goes into 4 twice. This is negative 2. 2 goes into 4 twice. This is 2 root 3. And remember, you have to tell it what it is. So x, y is equal to -2 to root 3 would be the rectangular coordinates for the same point. And if you plotted that again, if you like plotted it on a rectangular coordinate grid, if you overlapped a rectangular coordinate grid over your polar, they should line up. It should be the same point. Yeah, so it would, if it's an open-ended question. If it's multiple choice, no, but if it's open-ended, yes. I'm not going to give you a unit circle this time. You'll get the polar coordinate grid will be there.
Oh, okay.
But I would say you don't really, I mean, if you want to write you're over 6, you're over 4, you're over 3, I'd say go as far as that. Yep. Okay. Question 2, plot the given point in rectangular coordinates and then find 2 sets of polar coordinates for the point. Again, this time it's 0 to 2 pi. So in a rectangular coordinate grid, -√3, -1 would be -1.7 is what we would approximate root 3 to be. -1, so I go back 1.7, I go down 1, and that's where that coordinate would be. The idea there is for you to already determine what quadrant you're in, right? What quadrant is that point in? The third quadrant. So when I have 2 answers for my tan, then I know to pick the one that's in the third quadrant. That's the point of that. So now I want to find r. R is equal to square root of x squared plus y squared. So r would equal square root of -√3 squared plus -1 squared, which is the square root of 3 plus 1 square root of 4, which is 2. That's your r. And then I want to find theta. And tan theta equals y over x. We inverse tan it after we simplify it, and then we pick, because there will be 2 answers, we pick the one where the original angle, where the original point lies. So tan of theta equals -1 over -√3. And that reduces to 1 over root 3. And all the coordinate points we know for tangent are already rationalized, so I would rationalize that. Or understand that it's the same thing. And I get root 3 over 3. Positive root 3 over 3. So where is tan? Positive root 3 over 3. There's 2 answers, right? The over 6 in the first quadrant and the over 6 in the third quadrant. And we know to pick the third quadrant, which that over 6 is 7 pi over 6. And then I write it in polar coordinate form. So it looks like that. All right, now, hang on, let me find the other ones. Now it says find 2 sets of polar coordinates for the same point. So if my original point is 2, 7 pi over 6, I have 2 options. Keep the r, add and subtract 2 pi, or change the r and add and subtract pi. But my range is from 0 to 2 pi this time. So you want to keep that in mind because that restricts which ones you want. I don't want anything bigger than 2 pi. I don't want anything less than 0. So if I keep the r and I take 7 pi over 6 and I add 2 pi, which would be 12 pi over 6, it's going to be way too big. Keep the r, subtract the 2 pi. 7 pi minus 12 pi gives me -5 pi over 6, and that's too small, right? It's less than 0. So I don't want either of those. So my other option is change the sign on the r. So now my 2 becomes negative. Take my angle, add and subtract pi. If I add pi, I get, well, which would be 6 pi over 6. I get 13 pi over 6. Too big. I subtract pi. I get pi over 6. That's between 0 and 2 pi. Did I say 2? You only need to get 1 more. No, it says find 2 sets of polar coordinates for the point. So the original one that we got, that's the first one. Now I can only find 1 more, which would be pi over 6. And if I were to plot those 2, they should end up being the same spot, right? 2, 7 pi over 6 is 2 would be there. And pi over 6, which is here, -2 would also be in the same location. So those are the 2 between 0 and 2 pi. That would give you the same coordinate point. Questions? Okay, so this question came up on the homework. It said 9 root 3 and negative 9. So first of all, when I plot that, I'm going forward, okay, 9, and I'm going down 9. So I'm in the fourth quadrant. Of all the coordinate points there were 2 in the fourth quadrant. This one and this one, okay? But this is way past 9. Sorry. No, wait, hang on. It's 9 root 3. Yeah? Are they both right? Or that was marked wrong? That's weird. It shows that they're both right. I think something's wrong there. Anyways, that's where it would be, right? 9 root 3, negative 9, somewhere in the fourth quadrant. Then it said, which I think is what got most of you, to find the polar coordinates for it. The r equals, most of you got this part, right? 9 root 3 squared plus negative 9 squared. That's 81 times 3 plus 81. 243 plus 81, which was 342 or 324, and that is actually 18. Like if you break it all the way down or you square root it, you get 18. That's your r. Then your theta comes from tan of theta y over x, which reduces to 1 over root 3, negative 1 over root 3, which would be negative root 3 over 3. So I know it's an over 6. I know I'm in the fourth quadrant, which means my theta is 11 pi over 6. So the original point is 18, 11 pi over 6. And then the instructions said find 2 sets of polar coordinates. So that's the first one, 18, 11 pi over 6. But I need another one that falls between 0 and 2 pi. I can't add 2 pi to this. It would be too big. If I subtract 2 pi from this, it would be negative. It's too small. So then my other option is change the sign. So it would be negative 18. If I add pi, again, add 6 pi over 6, and I get 17 pi over 6. That's too big. So 11 pi over 6 minus 6 pi over 6. 5 pi over 6 is the only other option that works. Those two would have been your answer. So if you understand what you're doing, you don't actually have to, like if I know if I take something that's 11 pi over 6, if it's in the fourth quadrant and I add pi to it, or I add 2 pi to it, I'm going past 2 pi. You can save yourself some work. If you don't, then obviously you got to do some trial and error, like add, subtract, and see what you get. Questions before we move on. So we are going, all right, so this is 7. It said plot the point. So negative 7 pi over 6, I would go negative 7 pi over 6, and then negative 3 would bring it the other direction. So it was here, which was this one, right? That one. And then to find the additional polar representations of the same thing, so negative 3, negative 7 pi over 6. So this one was tricky because it was so negative. To find, if I wanted to keep the r the same, so if I keep the r the same, I could add 2 pi. So negative pi over 6 plus 12 pi over 6. And I get 5 pi over 6. So that one works. That was one. So then the other two, I would have to change my sign on my r. So I get 3 for those. And if I took negative 7 pi over 6 and added pi, I get negative pi over 6, and that falls in my range, so that works. If I subtract pi, it's too small because it would be negative 13 pi over 6, so I can't use it. So the rule is you can add and subtract odd multiples of pi, not just pi, which means if I take that negative 7 pi over 6, I can also add 3 pi to it. And negative 7 pi over 6 plus 18 pi over 6 gives me 11 pi over 6, and that still falls in that range. So it was tricky just because it was so negative you couldn't add and subtract pi. But if the same thing happened, if it was keep the sign and I added subtracted 2 pi and it was still too negative or too positive, now I can add 4 pi. So it doesn't have to be 2 and 1 pi. It could be even multiples and odd multiples. Okay. Does that make sense? Yeah. Okay. Can you go back? Sure. So 9-6, this is the thing about 9-6. It's weird. There's stuff in here you've never seen before, okay? One thing I think you've seen before, but that's it. And we do it even differently than we've done before. Today is going to feel weird. Tomorrow should be a little bit more familiar. And then hopefully by Monday we can review these and it gets a little bit more familiar. But the more you pay attention to how to graph these things, the easier it is in the long run, the less amount of work you have to do. If you have no idea how to graph these things, you're going to waste your life plugging in points and trying to figure it out. So I will teach you shortcuts, and tips and tricks to plot these. But if you don't have any idea, you fall back on literally plugging in points, which is how this starts. So first of all, you might see a polar graph that looks like this, okay, which is similar to what we had yesterday. The addition comes in the over 12s. So you see now all of these over 12s are added in. You literally could disregard them. It doesn't matter, okay? I'm not going to ask you to plug in pi over 12 to get a value, okay? Sometimes you would use them, like if you were plotting a point and it gave it to you as pi over 12, you could use it. But really all it does is it makes it more symmetric. It really breaks down the bigger space that's normally between the 0 and the pi over 6 and between the pi over 3 and the pi over 12, pi over 2. Other than that, literally just ignore them. It's just like the grid we did yesterday. So if I gave you a question and I said sketch the graph of the polar equation and I gave you r equals 4 sine theta, notice this is in polar. So instead of y, we now have an r, and instead of an x, we now have a theta. If you had no idea how to graph this, which I'm going to teach you how to graph it easier, but if you had no idea, just like every other thing you graph, you could plug in points. What you are going to plug in will be angles. So in place of that theta, we're going to plug in all the angles on the bottom. And we're going to do a lot of work with this question and then hopefully never have to do it again, okay? But the purpose is, should you get stuck, this is what you can do, okay? And there's going to be times where you have to plug in points, but never this many. All right, so I'm going to take each one of these and plug them in. So I get 4 times the sine of 0, okay? Now I got to know my sine all the way around my unit circle. So what is sine at 0? 0. Yes, the y at 0 is 0. So I get 0. What is the sine at pi over 6?
Root 3,
1 half. What is the sine at pi over 3?
3
Root 3 over 2. So I simplify this and I get 2 root 3. So remember earlier I said we want to know root 3. This is why. Root 3 is 1.7. You can make it 1.8. It doesn't matter. It's an approximation, okay? If you like an even number instead of an odd, pick the 8. Doesn't matter. So this would be 3.4. We're not going to graph a root. We're going to graph an approximation of the root. And I keep going. 4 sine pi over 3. What's the sine at pi over 2, sorry. What's the sine at pi over 2? 1. Then I keep going. 4 sine 2 pi over 3. What happens to my positive negative sign on sine as I go into the second quadrant? It's your y, right? Does your y change sign in the second quadrant? It's positive. So these values are going to stay the same as they were the first time at the over 3s, the over 4s. I mean, all of it would be the same. So the sine at 2 pi over 3, positive 1 half. No. Root 3 over 2. That's what I get for listening. Root 3 over 2 is 0 over 3. So I get 2 root 3. So I get 2 times 1.7 again, which is 3.4. And then I go 4 sine 5 pi over 6. And the sine at 5 pi over 6 would be? Now it's 1 half, and I get 2. And then I go to pi. 4 sine at pi. What is the sine at pi? 0. And I get 0. Now I'm in the fourth quadrant. I'm in the third quadrant, sorry. What happens to my positive or negative sign?
Negative.
Now it's negative. Good. So still the same value. So this would be 4 times negative 1 half. Negative 2. 4 sine 3 pi over 2. What's the sine at 3 pi over 2?
Negative 1.
Good. Negative 1. You're
Negative
right.
1,
Yeah.
sorry.
So then that's negative 4.
Oh, yes.
Now I'm in the fourth quadrant. What's true about positive or negative sign in the?
Negative.
It's negative in the fourth quadrant. So at the pi over 6, it was 1 half. This is negative 1 half. Negative 2 again. And what happens at 2 pi? What's the sign at 2 pi? 0. So notice there, if you look at your your r values, there's a repeat, okay? In the beginning, we were doing over 6s and over 3s. If I had continued to do that, the pattern would completely repeat. But we narrowed it down to just the over 6s in the bottom of your graph. Now we're going to plot it. So every one of these is a polar coordinate. The first one is 0, 0, which is on your origin. The second one is 2 pi over 6. So I go to pi over 6. I go out to the second ring. I put my point. The third one, 3 pi over 4 and pi over 3. I go to pi over 3. 1, 2, 3, 0.4. 4 pi over 2. Pi over 2 is at the top. 1, 2, 3, 4. 2 pi over 3 and 3.4. So at 2 pi over 3, I do 3.4. 5 pi over 6, 2. At 5 pi over 6, I go to 2. At pi, I'm back to 0. So I've doubled back to that point. At 7 pi over 6, this should have been a negative 2. Where did I write that? This is negative 2. Negative 2. Okay. 7 pi over 6 is negative 2. What happens when my r is negative? It goes the other way. So 7 pi over 6 is down here, but instead of coming towards it, I'm going away from it too. And it's the point that's already there. 3 pi over 2, negative 4. 3 pi over 2 is here, but instead of coming towards it, I'm going away from it. The point's already there. 11 pi over 6 and negative 2. 11 pi over 6 is here, but I'm going away from it. Negative 2 is here. And 2 pi, 0. I'm back to the origin. So this is a circle that would just continue to repeat and repeat and repeat and repeat. The goal would to never have to plug in that many points ever again, because we're going to learn some tips and tricks about a circle. A circle, honestly, a circle, you have to plot 1 point, and that is all you have to do. Okay? Because we're going to learn more about circles. But if you don't know how to do it, you're going to waste your time plotting those points. So the first thing we're going to learn that's going to help us is our symmetry. Okay, this, we're going to clean it up a little bit because it got, like when it distorted it. But this is one of the first things you're going to use to help you, and that is symmetry. So if I knew that that circle was symmetric to my y-axis, which we now call our pi over 2 line, if I knew it was symmetric to that that pi over 2 line, then when I got the right side of that circle, all I would have had to do is duplicate it onto the left side. I would have literally eliminated half my points. So anything that's symmetric to your pi over 2 line, which is the same thing as your y-axis, this is y-axis, that's what's behind there, okay? You literally can take your points and you can flip them over your y-axis or your pi over 2 line. Anything that's symmetric to the polar axis, which is your x-axis, you would flip over the x-axis. So if anything's happening in the top, I could flip it over the bottom, which will happen like if a circle is on my polar axis, it would flip over the bottom. And then the last one is respect to the pole, and the pole is the origin. Anything that happens in the top right corner is going to get reflected into the bottom left. Anything in the top left corner is going to get reflected into the bottom right. So if you understand your symmetry, it eliminates half your work because you literally can just flip your points over. That's one really easy way to eliminate some work, okay? These are, so at the top is the long description of symmetry. If you remember symmetry when we were dealing with our x-axis symmetry, if we plugged in a negative y and it went back to normal, then I would know it has x-axis symmetry. So the concept is the same. If it's polar axis, then if I plug in a negative theta, which is my input, it would go back to positive theta. If it's y-axis symmetry, then if I plugged in a negative x, it went back to positive x. This would be if I plugged in, let's say I took and this says negative r and negative theta. If I take and plug in a negative theta, it would give me a negative r, okay? And if you did polar axis, if you replaced r with a negative r and theta with a negative theta, then it would go back to normal. These you do not need to know though, because these on the bottom are your shortcuts. If your equation, and it only works if it's an r equals, we're going to talk about an r squared tomorrow, but if it has an r in it, r equals, and your function has sine in it, then it's symmetric to the pi over 2 line. If your function has cosine in it, then it's symmetric to the polar axis. So think sine is y, and y is your pi over 2. Think cosine is x, and x is your polar axis. So now go back to what we just did. 4 sine theta was my equation, right? And because it has sine in it, I would know it has its symmetry to the pi over 2 line, which would mean, again, I could fold it over, okay? That's your quick symmetry test.
So sine would be the polar? Or
No, sine is the y, which is your pi over 2.
origin?
No, sine is the y, which is your pi over 2 line, your y-axis. Cosine is the polar axis. So if it said for cosine theta, this would be a circle that's symmetric to the x-axis or the polar axis.
Got it.
Okay, so knowing that helps you, one, all of your graphs. Every single thing could have symmetry, and if it does, you can eliminate half your coordinate points. Two, it'll help you when, circles, it should make it really easy. Because circles, if you memorize this, you don't have to plot any points. If it is cosine, then it's symmetric to your x-axis or your polar axis, which means it's literally going to lie on your x-axis. If the A, which is the number at the front, is positive, then it's going to go to the right. If it's negative, my circle would have been on the left. And the distance you go out from the center, so 1 point's always at the center, the distance you go out from the center is whatever A is. A is your diameter. If your equation says sine in it,
It would flip upside down.
no, sine would be to the pi over 2, so left to right, like you'd fold it like this. And that would be on your y-axis or your pi over 2 axis, okay? And if it's a positive A, it's up, and if it's a negative A, it's under.
That's what I meant.
Oh, okay. So if I ask you to graph r equals 6 cosine theta, what does that circle look like?
It is going to lay on the right.
Good. It's on the x-axis, or the polar axis to the right. I'd start at 0. What far point do I go out to? 6. I make a circle. Not a circle. Close enough. If it said r equals -3 cosine theta, what does that look like?
It is going to go, yeah.
I start at 0.
And then you go to 3
I go to -3.
and -3, sorry.
I make a circle. Yeah? Easy stuff.
And it's not bad.
No. And if you forget, you could always plug in a point. Like I could plug in 0. I could plug in pi over 2 and see, is it here? Is 0 going to give me the -3? Or is 0 going to give me the pi over 2? Or is 0 going to give me the, like that? Like you can always plug in those coordinate points. I mean, is 0 going to give you the radius? Is pi over 2 going to give you the radius? Or is 3 pi over 2? Like you can figure it out from there. Yeah.
What would a question look like?
I mean, a circle one will literally say, graph this.
Oh,
Yeah.
so if you didn't know that shortcut,
You'd have to plug in some points. Yeah.
So the first slide, you'd only have to do that if you.
I mean, this is one. So we're learning circles. We're learning something called limicons. We're learning something called roses. And we're learning something called lemniscates. Circles is the easy one. Circles is the one that you don't have to, all you have to do is understand what you're doing and you don't have to plug in points.
So are we learning all those in
Tomorrow.
Okay.
Yep. So if you didn't remember which way it goes, and let's say I wanted to figure out, like plug in 0, right? Cosine at 0 is 1, and I get -3. So my r theta would be -3, 0. I'd go to where my radius is 0, my radians are 0, and instead of going towards it, it's negative. So I go away from it, and that's how I know that point goes there, which confirms your circle. So if you forget or you're unsure and you're graphing your circle, you could plug in a point. You just wouldn't want to waste time doing a lot because this one should be easy, okay? Questions? So tomorrow we're going to learn 3 different types of polar equations tomorrow, okay? You guys need to bring your A games, people. Like, wake the brains.